Welcome on. Today we are discussing about the uh, buck converter, which is DC to DC converter using the MATLAB software. Here we go to the simulation. Here the Simulink block, create model. Basically, what is buck converter? It is basically a DC to DC converter, which steps down the input voltage with corresponding to the duty cycle of the switching frequency of the MOSFET. Here is the library browser. Here we can pick the components for the buck converter. First, the source DC voltage source, which is the input for the buck converter. Next, MOSFET. Next, we are going for the filters, the inductor and capacitive filters. This inductive filter for rotating, press Control plus Alt R. Next is the load for the buck converter, the diode. For the switching of the MOSFET, we need a pulse generator. Click the MOSFET. We we shall need not measurement for the MOSFET. Just unclick it. By unclicking, the design of the MOSFET is modified like this. Does not show the measurement port itself. Interconnecting. For rotating, the shortcut is Control plus R. Here also measurement port is not needed. Just unclick it and then apply. giving pulse to the MOSFET for measuring voltage. We need a voltage measurement block. For visualizing the output, we need a scope. Labeling the components. Assigning the values for each components. 100 volts is very much a huge amount of voltage. It is essential for the buck converter to step down the voltage. So why it is assigned as 100 volts. Input filter value is 1.73. The filter values are based on calculation only. We can refer in the standard design. It is the simulation stop time, uh, where we can stop at a specific time, etc. can be handled in its dialog box. Pulse generator. It is the main component for the switching of the MOSFET to essential output the buck converter. Here is the amplitude 1 volt. Period is about 10 seconds. We should change it. For this change, we should know the switching frequency of the MOSFET. It is about 25 kilohertz. In time domain, we can see the value. Time is inverse of the frequency. So 1 divided by 25,000, which is the 25 kilohertz. Value is 4 e power minus 5. This paste in the value. Okay. In this block parameter, pulse width, it is a major parameter which determines the output voltage. Here the buck converter, the output voltage is uh, pulse width percentage into the input voltage, but multiplied with the input voltage. So we choose 50% of the T on time. running. Let's see the output. Yes, 50 percentage of output is available at the load. 50%, which is 100 voltage at the input. 50% means 50 volt at the input, output at the load. For clear visualization of the output with change in voltage, that is del V, we can visualize it. By varying the time, we can see clearly. Here we can see the change in voltage. That means del V. For the design parameters, you may know changing the pulse with percentage considerably vary the output voltage, etc. For 20%, we can see the output. Yeah, the output voltage is 20. For 20%, it is about 20 volts. So, for higher voltage, the voltage decrease at the load with respect to the pulse width of the switching frequency. That means the switching frequency of the MOSFET remains same, but the pulse width of the pulse train is varied. So the output voltage also varied according to it. This is the principle of the buck converter, which is normally called as DC to DC converter or the step down converter. Thank you.